Hello students, now we will study about uniform and non-uniform acceleration. So what is uniform acceleration? Uniform acceleration, we can say that if a body travels in a straight line and its velocity either increases or decreases in equal amounts in equal intervals of time, then the acceleration of an object is said to be uniform. And example that we have a motion of a freely falling body. Now let us try to understand what we mean by this. If an object travels in a straight line and its velocity increases or decreases by equal amounts in equal intervals of time. So I have a diagram over here. I hope we can all watch this diagram. Over here, this is a straight line. Suppose a body is moving along this straight line. This is the starting point, or which is also known as origin or the reference point. Now this entire path has been divided into different intervals, right? Or the entire path has been divided into various small parts. Now suppose in the first second the body is moving with a velocity of 2 meter per second. Over here in the second interval, again 1 second it travels with a velocity of 4 meter per second. In third interval, again it is traveling with a velocity of 6 meter per second. Similarly, in the fourth interval, that is CD, the time taken is 1 second and the body travels with a velocity of 8 meter per second, and so on. So what do we see? We see that an object is traveling in a straight line and its velocity increases in equal amounts. Like for example, over here the increase in velocity between these two intervals is 2 meter per second. Over here also increase in velocity is how much? 2 meter per second. Over here also increase in velocity is 2 meter per second. So if an object is traveling in a straight path and its velocity increases in equal amounts in equal intervals of time, such a kind of a motion is known as uniform, or you can say such a kind of an acceleration is known as uniform acceleration. Now it's not necessary that the velocity should increase in equal amount. If it is decreasing in equal amount also, then also it is a uniform acceleration. As we already know that example of a uniform acceleration is a motion of a, say, freely falling object. When something falls from the sky, it's an example of a uniformly accelerated motion. Next is non-uniform acceleration. Now non-uniform acceleration is if an object travels in a straight line and its velocity does not increases or decreases in equal amount in equal intervals of time. Such a kind of an acceleration is known as non-uniform acceleration. The best example is a car running on the road. Now let us try to understand this. We'll understand this by a help of an diagram again. That what do we mean if an object travels in a straight line and its velocity does not increases or decreases in equal amount in equal intervals of time, then the acceleration is non-uniform. Let's understand this again by a help of an example. So here we have made a diagram for this also. Now suppose an object is traveling in a straight path and these path is divided into equal intervals. That means equal parts. Now for the first second or during 1 second, the object travels with a velocity of 2 meter per second. Again in the second interval, which is of course in the next second, an object travels with a velocity of 5 meter per second. In the third second, it travels with a velocity of 6 meter per second, and in the fourth second it travels with a velocity of 8 meter per second. So what do we notice from all these from over here? We notice that though the object is traveling in a straight line, but its velocity is not increasing in equal amount in equal intervals of time. Here though the time intervals are same, equal, 1 second, 1 second, 1 second, but the change in velocity in each interval of time, like for example here it was 2 meter per second, it was 5 meter per second. If you find change in velocity, it will be 5 minus 2, 3. Over here between these two intervals, 6 minus 5, 1. So if an object is traveling in a straight line and its velocity is not increasing in equal amounts in equal intervals of time, so such a kind, and the vice versa also, like for example its velocity, suppose an object is traveling in a straight line and its velocity does not decreases in equal amounts in equal intervals of time, so we can say that it is a non-uniform acceleration. The best example is when you are running your car in a market. So that's the best example of a non-uniform motion, because sometimes you'll be fast, sometimes you'll be slow, so you cannot say that your acceleration is constant. Now here we have a question that is given to us. Starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meter per second in 30 seconds. Then he applies brake. Sorry, I will have to readjust it. Starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meter per second in 30 seconds. Then he applies brake such that the velocity of the bicycle comes down to 4 meter per second in the next 5 seconds. Calculate the acceleration of the bicycle in both cases. So here we have in this question, if you look carefully, this question is divided into two parts. First, when he starts bicycling, he attains a velocity of 6 meter per second in 30 seconds, and he starts from rest, that is stationary position, and then after bicycling for some time he applies a brake, and when he applies the brake, what happens? The velocity of his bicycle comes down from 6 meter per second to 4 meter per second in 5 seconds. So you have to calculate the acceleration of the bicycle in both cases. So let us try to solve the first case now. In the first case, initial position is 0, as it was given over here, that's starting from the stationary position. So stationary position means initial velocity will be 0. Rahul pedals his bicycles to attain a velocity of how much? 6 meter per second in 30 seconds. That means the final velocity will be 6 meter per second and time taken is 30 seconds. So we know the formula of acceleration now. A is equal to V minus U upon T. Now we'll put down the values over here in the given equation. What do we get? Final value of velocity is V, which is 6 meter per second. We have put it over here. Initial velocity U, we have put down it over here. Final value, that is final velocity minus initial velocity, time taken is 30 seconds. So we have put down here also. So when we solve this, 6 minus 0 is 6. 6 by 30, that is that will give us 1 upon 5. 1 upon 5 is 0.2 meter per second square. So acceleration over here in the first case is positive, as you can see, since the velocity was increasing with the passage of time. That is 0 to 6 meter per second, velocity is increasing, passage of time is 30 seconds. Second case, what do we have? In the second case, we have the bicycle was already moving with a velocity, initial velocity of 6 meter per second. He applied brakes and velocity came down to 4 meter per second, and the time that was taken was 5 seconds. Then what do we have? We will apply the formula again. A is equal to V minus U upon T. So final velocity is 4 meter per second, initial velocity is 6 meter per second, and time taken is 5 seconds. So what do we get? When we solve this, we get the value as minus 4 meter per second square. So that means the acceleration is negative over here in this particular case. So when initial velocity is greater and final velocity is less, the acceleration is negative.